we were taking a look at this triangle and wondering, if we connect the midpoint of one side with the midpoint of another side, will that segment always be exactly half as long as the third side? So to explore if this mid-segment is half as long as the third side, we began by strategically placing this shape into the XY plane. So we'll do a combination of sliding and rotating. So that one corner of our triangle is at the origin and another corner is on the x-axis. All right, so now we need coordinates for the three corners of our triangle. The origin's coordinates are 0, 0. For this coordinate, we're not going up or down at all, so the y-coordinate is 0. But for the x-coordinate, well, that could be any length from here to here, so we'll use the variable a. And then for this corner, we don't know how far left or right we went, and we don't know how far up or down we went. So we'll need new variables. Let's say we went b units to the right and c units up. All right, so in this problem, we're going to try to prove that the pink segment is always 1/2 as long as the third side. All right, so we're going to prove that that pink mid-segment, we'll call it segment midpoint 1, midpoint 2, M1, M2, its length is 1/2 the length of the blue side, PQ. Here we go. First, we'll find the coordinates of M1 and M2. So M1 is the midpoint of P and R. So using the midpoint formula with the coordinates of P and R, M1 is A over 2, 0. For M2, it's the midpoint of Q and R. So we'll add the x-coordinates A plus B, divide by 2, and we'll take the y-coordinates 0 and C and divide by 2. All right, we now have the coordinates for midpoint 1 and midpoint 2, and our reason and our proof is the midpoint formula. What next? Well, we're ready to find the distance of this segment M1, M2. We know the coordinates, so now we can find the distance. We also need to find the distance of segment PQ. So we're going to find the distances of PQ and segment M1, M2 using the distance formula. Here we go in step 2. All right, let's find the distance from P to Q using the distance formula. So the x-coordinates are B and 0. And the y-coordinates for segment PQ are C and 0. B minus 0 is just B, so we'll have B to the second power. And C minus 0 is just C, so we'll have C to the second power. And this is where we stop. There's no more simplifying to do here. You cannot make the square root get rid of these squares because of this plus side. So this is it. Stop right there. And now let's find the length of the pink segment, M1, M2. All right, first we'll subtract the x values. So here we've got the coordinates for M1 and M2. So the x values will be a plus b over 2 minus a over 2. All right, next we'll subtract the y values for M1 and M2, which are c over 2 and 0. All right, well, we've got fractions here, and we do have common denominators. So when we subtract these fractions, we'll keep the denominator of 2, and we'll subtract the numerators, a plus b minus a. A plus b minus a leaves us with just b over 2. And over here we have just c over 2 squared. All right, we're able to find the distance from P to Q and the distance from M1 to M2. That is the length of this segment and that segment using the distance formula. Now we just need to show that the pink segment's distance is exactly half of the blue segment's distance. So for that, we're going to do some algebra. So the blue segment, as we figured out, had a distance of the square root of the sum of b squared and c squared. And the mid segment had a length of the square root of the sum. And let's go ahead and square b over 2. When you square that, we get b over 2 times b over 2, which is b squared over 4. And c over 2 squared is c squared over 4. So doing some algebra, we have common denominators. So we can rewrite this as b squared plus c squared over 4. And then you learned in algebra that we can rewrite that as the square root of the numerator divided by the square root of the denominator. And what is the square root of that denominator? 2. So let's look at what we've got now. The blue segment's length is the square root of b squared plus c squared. And the pink segment's length is the exact same thing, except it's divided by 2. So we've now proven that the pink segment is exactly the blue segment divided by 2. It's half of the blue segment. So we can just say at this point, we've proven that the mid segment is half as long as the triangle's third side. Our reason? A bunch of algebra and arithmetic. No, there will not be any problem as hard as this on next week's test. But we do expect you to be able to follow the reasoning where we use midpoint formula to find those points and the distance formula to find the length of these two segments.